Welcome to NOAA Live. My name is Nicole Bartlett, and I'm going to be moderating today's webinar. This series is sponsored by NOAA's Regional Collaboration Network, where I work, which is spread across the country and helps connect people to all that NOAA does. Our amazing partner in this effort is Woods Hole Sea Grant, and they're located at the Woods Hole Oceanographic Institution. You can click on their website education tab or follow them on Facebook to find out about our future webinar offerings. This is the 18th webinar in our series. We're wrapping up 6 weeks so far, halfway through, designed to help you get to know NOAA and some of our incredible experts during these months of school closures. By now, some of our regulars know that NOAA, NOAA, stands for the National Oceanic and Atmospheric Administration. Today, we're introducing you to Gary Shigenaka and Charlie Henry, both with NOAA's Office of Response and Restoration. Gary is in Seattle, Washington, and Charlie is in Mobile, Alabama. While we'll be talking about NOAA's role in oil spill response, we want to recognize that we are all coming to you from the traditional lands of Native communities who have substantial traditional and local knowledge and much to share with us. We acknowledge Gary is coming to us from the land of the first people of Seattle, the Duwamish, and Charlie in Mobile, Alabama, from the land of the Creek Nation. We are hosting this webinar from the ancestral lands of the Mashpee Wampanoag tribe and the Wampanoag tribe of Gayhead, Aquinnah. A few guidelines before I hand you over to our speakers. You're all muted because we have a lot of people on the line and we want to make sure everyone can hear our speaker. However, there's a box where you can write questions. We encourage you to ask them as we go, and I'll be keeping track for Gary and Charlie. They'll stop every now and again and answer a few. We may not get to all of them, but we will definitely try. So without further ado, I'm going to turn it over to you, gentlemen, and I will catch up with you on the first break.
All right.
Well, good morning, everybody.
Okay. Well, Gary, where are we starting at?
Let's
go to the first slide, and we can talk a little bit. Hi. So I'm Charlie Henry. I'm the guy that you see on the left. And we are really pleased to be here today. It's kind of a break in our day to do this. We're actually not in our offices. We're all talking to you from our homes like you're in your home, and that's kind of unusual for us, but we're really happy to be here. And we'll tell you more about ourselves and what we do and ask a few little questions and show you some interesting pictures as we move forward. But Gary, you want to do a quick introduction?
Sure. Good morning from Seattle, sunny Seattle for a change. And as Charlie said, we're really pleased to be doing this. It's kind of fun. It's a little bit of a new experience to talk to people across the country and maybe even in different countries. So this is cool. And we're hoping that you get something out of it and that you learn a little bit and get a little bit of entertainment value as well.
Cool.
So Charlie, you want to begin by telling everybody, what does NOAA do during an oil spill?
That's a good question, Gary. So NOAA, as you might know a little bit about NOAA from the other presentations, is we're a science-based organization. Most of the people that work in NOAA are either scientists, or they support science, or they do all the other work that allows scientists to do the work that they do, which is real important, like operating the aircraft and operating the ships that we have. What happened on this is we're not in charge of oil spills as far as NOAA, but we're always often asked to participate because we are the science experts that supports the Coast Guard and others that respond to the spill. So we're often asked, come help us. We have a problem and we need your insight as being a scientist on how things work in the environment to know if the decisions we make are good or bad decisions as far as the resources, the animals that live in those ecosystems, and the recovery of the environment. So they rely on our expertise as scientists to know the environment and help guide them through the decisions that they make. And so the picture that you see here is one of our fellow NOAA science support coordinators during an incident, and he's wearing the gray coveralls. You can see the NOAA beat ball on his coveralls, and he's going over some things with two of the Coast Guard people as they're looking at probably tactics for cleaning up an oil spill. So And there's a lot of things that guide what we do. You know, when we get called to come to an oil spill, or you know, let's say when most of my career, for 25 years, my career was getting called in the middle of the night by the U.S. Coast Guard saying, "Hey, Charlie, we have a problem," and we start going over the problems. And when they get that call in the middle of the night, and I start thinking through the issues, I have to kind of put together a mental picture of what's really going on, so that even though I'm not there looking at it, I can start to understand it. And that mental picture is really driven by 5 different questions. And Gary, were you going to talk about those questions, or do you want me to?
Oh, you're on a roll. Go ahead, Charlie.
All right, I'll be happy to continue. So the first thing that I want to know when I get called in the middle of the night, and remember, you can't see anything. All I have is a phone when these incidents start, because later on we'll be on scene. We'll see things with our own eyes. But early on, I want to know, well, what got spilled? These are the 5 questions. So the first thing I want to know is what got spilled. And for what we're talking about, it's going to be oil spill. So what kind of crude oil? And in this jar, which is hard to see, is actually a sample of crude oil from an oil spill. And it's very sticky, tacky, black oil, and that's one of the reasons it causes problems when it's spilled in the environment. This comes out of the ground, and it's before it's been refined in refineries to make products that we use all the time, such as the gasoline in our cars and different oils we use for different things, or even records and other plastic items. So I need to know a little bit about this, because all oils are different. So I need to know a little bit about the oil. Then I need to know, the second thing I need to know is, where is it going to go? Because there's lots of things that move oil around in the environment, and one of the things they want to know from us is, where is it going to go? And that's driven by the currents and driven by the winds and the behavior of the oil as it interacts with the ocean. So, and whether it actually sinks or floats, there's lots of pieces on that. So I want to know, where is it going to go? Then I want to know, depending on where it's going to go, what lives there? What could be affected? Is it going to be impacting a shoreline? Is that a marsh, or is it a sandy beach? What is there? Is it a very important rookery for certain types of birds? Lots of things it could be, but I want to know, because I need to know what could be impacted. And I need to know what kind of harm it could cause. That's the 4th thing that we asked about in our mind, is we're going, okay, so oil's going to be there, but how's it going to hurt? And then once we kind of figure that out, we can help guide the decisions on which is the 5th question in my mind, what can we do to help and make things less bad and protect the marine resources and help with recovery so we can get back to the way it was before the oil spill. And those are the 5 questions that are constantly going in our mind as a scientist, as we're trying to understand the problem, so we can provide guidance to the Coast Guard and to others on the decisions that we make to respond to an incident. So that's kind of what our role is as a scientist during an oil spill. Gary, you want to move on? So I guess I'm still up. So how did I get where I do and what I do? People ask me all the time, so how did you get to be an oil spill scientist and go all over the world and do fun things, which aren't always so fun, but it looks fun to other people that aren't there? And I have to say that my roots actually started no different than where you are sitting right now. You know, when I was a student in high school and elementary school and middle school, and what I always wanted when I was growing up, I wanted to do one thing, and that was to fly jet airplanes. That's all I cared about. I didn't want to do nothing else but to fly jet airplanes. And so when I got out of high school at 17, I joined the Air Force because I wanted to learn about jet airplanes. And so I spent some time in the military learning everything about jet airplanes, how to repair the systems, the avionics and radar systems. And it was real important, because a lot of the stuff I learned learning how to work on airplanes and troubleshooting airplanes actually turned into be no different than how we troubleshoot or look for how to solve problems during oil spills. Well, so after I did some time in the Air Force, I went to college with the whole idea that I'm going back in the Air Force, I'm gonna fly jets now. That's all I cared about doing. But once I got into college, I started to really fall. I loved chemistry and I loved science. I loved the marine science especially. And before I knew it, that my passion was no longer flying jet airplanes. My passion was to do science. And so that's what led me to move into a scientific field. And then how I got into oil spills was more, and opportunities were there. I didn't say no, and I started working on issues related to oil spills. And over time, you start to become one of the experts on oil spills, and that became most of my career, was working on oil spills. And so I've done that for a long time. We'll show you some pictures and talk about that. Some of the pictures that you see there on the right, you know, show me doing some field work like in the Everglades. And this is what I usually really liked about marine science and research is this was a project we did down the Everglades where we'd land helicopters with floats on it onto the Everglades, these big swamps down there. And then we'd jump off out of the helicopters into the swamp and walk around. And you see the alligators and everything else around and collect samples because we were studying changes in that habitat. So one of the things I really like about being a scientist is the field work we do, the opportunities that we have. And I'll talk more about that as we go through. Next slide there, Gary. So as a spill response scientist, you really have to know the environment that you're working in. You cannot give very good advice to other people if you don't really understand the environment that this event is taking place. So you have to know the environment to be able to talk about how oil behaves in the environment. And you have to be a good observer to understand the environment, because we learn all the time. This is not, all the science is not known. There's a lot of science we don't know. And one of the roles of a scientist during a spill is to look at things that we didn't understand and understand those better. So we call it get smarter later. And so we spend a lot of time doing that. But it does give you a lot of opportunity to get out into nature and to really study nature and to learn to appreciate nature. So here's just a few slides. One would be playing with a little alligator from an incident, looking at some oiled sea otter down in a spill that we had down in the Galapagos Islands, flying around in helicopters. You spend a lot of time flying around in helicopters. Down in Kuwait during some oil fires in Kuwait in the Middle East, testing different types of treating agents, dispersants you can work on oil spills, diving to to the platforms that where oil is generated from in the Gulf of Mexico, do some diving. And I guess the last picture on that is Gary and I doing some research in Alaska after the Exxon Valdez oil spill, working out these small little Zodiac boats. I will tell you, I would tell you a story about Gary and I getting out in a little boat and in the winds and waves coming up and bouncing us all around. I kept looking at Gary, why are we in such a little boat, this big ocean? But that's some part of the fun of it as well. But we did fine, we survived. Next slide. So that's my background as a scientist, what I do as a scientist. And I did that for a long time. And then after a while, what I did during oil spills, like there was a big oil spill 10 years ago called the Deepwater Horizon oil spill. And it started like all these other spills. I get a call in the middle of the night saying, Charlie, we got a problem. We have an explosion offshore, and it's really a bad one. We have people that have been killed, and we really don't know what else is going on, but it's something that really could be bad. And that's that first picture that you see with this big fire. That's the semi-submersible Deepwater Horizon on fire, burning, and oil coming up from a mile below the ocean and burning, and it's a very bad situation, and it can be really bad. We'll talk more about that as we go. But I found my role on that one was not so much being, the role I usually am. If you ask my daughter, you say, what does your dad do? If you ask my daughter what I do, my daughter would say something like, well, Dad, he flies around in helicopters, goes to really cool places, see cool things, and tells people what to do, how to clean up oil spills. Well, it's not really that way. As we talked about, we're an advisor role. On the Deepwater Horizon, I found my role actually more working with the press, talking to the press and providing information. I was a lead science advisor to the Coast Guard, but I spent most of my time working at the command level, where we would really try to relay that information that scientists like Gary in the field were learning, and relay that information and pass that on to the public. We also did a lot as far as designing science to answer questions that we didn't know, and that shows you this sampling device that's there on the right. And I got to spend a lot of time talking to governors and congressmen and senators and trying to answer their questions, because they were all really concerned. So I got the fortunate role of being in the spotlight, but the unfortunate role of not being able to be in the field. I spent very little time in the field during the Deepwater Horizon, and Gary spent a lot of time in the field. So he'll tell you a little bit more about what he learned, and I was just the guy in the background on that spill. So Gary was the real environmental hero in the field during that one. But we're all a team. There was more than, and Gary will talk about the team. There was not just Gary and I. There was a lot of people that were doing a similar job, all for the same in common good. Gary, go to the next slide if you would. So I did have a question for you guys. Now, you might not remember the Deepwater Horizon oil spill. It was a long time ago, and you might not have known too much about oil spills then. But it was the largest spill in the marine environment in the U.S. Not the largest spill in the world, and not even the largest spill in the U.S., but the largest oil spill in the ocean that we've ever had to deal with in the United States. So I got a question for you. And it's about how big it was, because it gets lots of attention because it was a big spill, but how big was it really? So the question I'm asking you is, how many gallons of crude oil were released into the ocean during the Deepwater Horizon oil spill? And so, I'll give you a multiple choice, makes it a little bit easier. Was it 2,100 gallons? Was it 2,100,000 gallons? Or was it 210 million gallons of oil?
All right, well, let me tell you, this is, we got a lot of engagement on this question, and let's see, Luke and Kyle and James all think it's C. And then who else? Oh, I'm sorry, Kyle thinks it's B. Taylor and Duncan and Michael and Juan. And yeah, we're getting a lot of B's right now. That seems to be the majority view.
Okay, and a spill of any size like this, if it's only 2,000 gallons or 2 million gallons or 200 million gallons, they're all bad. So it all depends what the oil is and impact known. But the answer is C. So those that thought C is right. But just how much oil is that? I mean, trying to put even myself as a scientist, I have to kind of put in context that amount of oil. That's a big number. So if you go to the next slide, I'll show you how I was thinking about this oil. So we don't have gallon milk jugs in my house, but we do have half gallon. So think of a jug twice this size. And everyone knows those gallon milk jugs that you see around. And you probably have them in your refrigerator. So each of those jugs is a gallon. So it was 210 million jugs of milk spilled, but the milk was oil. And so what does that really mean? So I thought in my mind, I said, all right, so if I put these things side by side, like you see in the picture here, how big of an area would that cover with oil 10 inches deep? And it really would cover 774 football fields with 10 each deep oil, because that's the height of those jugs. And if I put them just one after another in a series, it would be a line 18 miles long. So it was a lot of oil, trust me. It was a big spill. Next slide. So this is about how Gary got here. His story is really interesting. So Gary, it's all yours. So, yeah.
Well, it looks like we're out of time now. So thanks for tuning in. And no, just kidding. I'm Gary, and I have always had an interest in water and the things that live in water from the very beginning. And when I was a kid, I happened to tune into a TV show called The Undersea World of Jacques Cousteau, which sort of it changed my whole world. And I really took an interest in trying to study the ocean. So I went to the University of Washington and studied oceanography and marine biology. And after I graduated with a bachelor's degree, I took a bunch of jobs working on the water. I wanted to learn as much as I could about salt water in particular. I found that really interesting. And so over the years, I worked on NOAA ships, but really just had this innate love of the critters that inhabited the marine world. So that kind of certainly steered me toward the ocean and studying the ocean, but it also began to awaken an interest in trying to protect ocean resources. So I thought I would show a couple of slides about what I do as a marine spill scientist. And because many of you don't know about these spills, I'll begin with the background slide of the spill. So this is the Exxon Valdez spill up in Alaska. It happened 31 years ago. And it was my first spill. And I did something that a lot of our scientists do, a shoreline survey team, to go out and look at where the oil is. But then I also worked on a long-term monitoring program up in Alaska to look at the effects over time of that spill. And this is a shot actually of me working with my son. So when the spill first happened, he was not even a glimmer in his father's eye yet. He wasn't born until 6 years after the spill. But I was fortunate enough to have him come up to help me out on some of the research that we conducted over a long period of time, over 13 years. Charlie mentioned the Deepwater Horizon, of course. That's a big spill in the Gulf of Mexico. Happened 10 years ago. You know, it involved like this wellhead that wouldn't stop leaking on the bottom of the ocean a mile deep. And I did a lot of things. You saw this shot as an advertisement for this talk. But a lot of what I wound up doing during the Deepwater Horizon was talking to people to try to communicate the science that we were learning over time. And this shot down here in the lower right is in the forward command post. We gave a tour to Miss Louisiana in the Miss America contest, who you know, just represented the public. She had an interest in what was going on in her state. So that was part of the whole communications thing that we did to try to translate the complex science that we were trying to understand and turn that into something that was understandable to members of the general public. Part of that involved trying to take these very complicated issues, like, is the seafood safe to eat during an oil spill? And we would prepare information sheets for the general public. And during the Deepwater Horizon, it was even more challenging to do that because we had non-native English speakers. For example, the Vietnamese, there's a big Vietnamese community in the Gulf Coast. And so we had to translate our science information sheets into other languages. So it's just part of that challenge of trying to communicate science. Charlie mentioned that occasionally we get the opportunity to go to other countries. This is an oil spill in Bangladesh that I worked on about 6 years ago. It was not a huge spill, but it was in a very, very sensitive area, United Nations World Heritage Site called the Sundarban in Bangladesh. And so in that spill, it was more of what we do. It was trying to assess what the oil was doing and then communicating some of the issues as we saw it from our science perspective. And it was a multinational team. We had people from all over the world who came to assess this spill on behalf of the UN and then provide guidance to the government of Bangladesh. And then more recently, this was not a huge spill, but it's a big incident that is ongoing in the state of Georgia in St. Simon Sound. So this photograph shows a car carrier that was outbound from Brunswick, Georgia, and it overturned. It ran aground and then it turned over. So this just happened last fall, and I had the chance to go and support that and try to understand the impacts of oil that was leaking out of this big ship and the 4,000 cars that were on board that ship. This particular photograph, you see the blue hull on top of that ship right there. We did an experiment where we put oysters inside the hull of the ship to see if they would sample the contamination that might be in the water. And that's what it looked like inside the cargo hold of that ship.
Can I
so
stop
here's a question for all of you.
Okay, go ahead, Gary. Go ahead,
right.
Gary.
I was just going to get to a question. It's a basic question. We don't have a lot of time to go into this. We don't have any time to go into this, but here's a question for all of you out there. So when there's an oil spill, how do you clean it up?
All right. Does anybody have any ideas? James thinks you filter the water. And we were getting a couple of I don't knows. They're very curious about it. Someone says you can suck the water up, like suck the oil up, or burn it. Oh, there's a word in here that I think you're going to talk about. Chris says dispersants. There's also nets. Someone says, is there a net you can put around it, or can you add bacteria that might break it down, or use special sponges?
Well,
are any of those
are really great. those are all great ideas. Now, here are just some photographs of the ways that you can clean up oil, both on the water up on top there, and then when it comes ashore, just different ways that people have cleaned up oil in the past. And like I said, we don't have time to go into all of these. And in fact, when we teach about the science of oil spills, we spend a lot of time going through each of these photograph types and explain when and where you can use them. I'll give you Charlie's home phone number if you have any questions about how to clean up oil. And so, like I said, we don't have time to go in here, but you can at least see some examples of how people have addressed it in the past. Scooping it up, like somebody said, spraying dispersants or other chemicals on it, burning it. You can kind of sorb it up on plastic material, pick it up manually, or you can use heavy equipment too.
Gary,
so,
Gary,
yes.
before you continue on for a second, can we pause and take some questions from the kids? They've been sending some in as you guys were talking.
Oh, absolutely. Yeah.
Okay, great. So back, can you talk about some of the reasons? Sloan would like to know, why does oil get spilled? So can you talk about that a little?
Sure. Well, how does oil get spilled? Well, one thing is it's got people involved. People sometimes have accidents. That's why there's sometimes car accidents. That's why sometimes you spill a jug of milk when you're trying to carry it from the refrigerator to the table or anything like that. So accidents do happen. The reason we want the oil is because it's become a very important commodity for us to use as a raw material for energy and to make different products that we want. So that's why there's a need for oil, because we've created that need. In the process of drilling the wells, there's a lot of unknowns, and sometimes things happen that they cannot control, and you get a wild well blowout. That happens every once in a while. When they do get the well in place and they start to collect the oil and they put it on a vessel, and that vessel goes somewhere, just like Gary showed with the car carrier, sometimes accidents happen with those vessels. They make mistakes or get into storms that maybe they didn't recognize was going to happen, or they hit something that we didn't know was there. Sometimes debris from a hurricane creates debris that sometimes they may hit if we don't find it fast enough. So the accidents happen that way. And, pipelines can corrode and accidents happen. So overall, the reason why we have oil spills is because we produce a lot of oil. We have to take it to the refineries. And in that process, sometimes oil is spilled because accidents happen. And then at the refineries, it comes out of the refineries and it gets used in industries. And sometimes they have problems and oil spills, like a tank will fail and you spill diesel fuel, things like that. So nothing's ever perfect. So you can never come up with a perfect system, because there's always going to be things that can happen and oil gets spilled. It's just part of producing oil. That's a good question.
Yeah, that's a great response too. I don't think we think about all the transport that has to happen to get oil places. Let's see, Juliana and James would like to know, how many different types of oil are there? You talked about having to find out what type there is. So is there a lot of different types?
That's the one I'll take, Gary, because I'm more of the chemist. Gary's more the biologist. We're both scientists, but our disciplines are actually complementary but different. How many kinds of oil there is? There's unlimited different types of oil. Oil that's drilled in the Gulf of Mexico, oil that's drilled in the Middle East, oil that's drilled off of California, oil that's drilled and produced in Alaska, oil that's drilled and produced in Canada. It depends on where you are in Canada. All of these oils come from old organic material, blue green algae that got buried and didn't degrade all the way real quick. And then over time, buried deep in the earth, underwent a lot of changes and made oil. And it all depends on the different temperatures and pressures and the different organic material. So the end result, and how long, the end result was all these oils are different. And that's part of understanding. Some oils are really light and they evaporate or cause explosions and fires. Other oils are really heavy and they sink right to the bottom of the ocean and make it even harder to do cleanup. So it's, I cannot put a number on it, but every day new oils are added to that list. So it's in the millions and millions of different oils that we deal with. And understanding that chemistry is part of the important part of being able to understand how the oil is going to behave in the environment.
Wow, I had no idea there were that many different kinds of oil. Gary, Raven would like to know, is your job hard?
No, it's a piece of cake. No, of course, it's hard. It can be challenging, very challenging. And I think one of the most challenging aspects of what we do is the people aspect, because, you know, a lot, as I mentioned, a lot of what we do is try to communicate the complex science behind oil and oil spills and oil spill cleanup to people who may not understand it very well. And so they get scared. And it's very reasonable that people who don't understand something, whether it's oil or dispersants or something else, they get frightened. So that's a big challenge, to try to reassure people that we're trying to use the best science that we have. But it's not an easy task, I have to say.
Well, Stephen in Florida is asking, with that in mind, what would be your favorite part of your job then?
Well, it's kind of the flip side of that coin. We never know exactly what's going to happen at an oil spill. And so you have to be nimble on your feet. You have to be kind of a quick thinker and be able to respond rapidly to challenges that come up. So if you like that sort of thing, then it can be a very rewarding kind of career. And I want to get into the risk and rewards at the end, but we'll touch on that a little bit.
Thanks, Gary. What about you, Charlie? What's the favorite part of your job?
I guess that's what my daughter said. I get to fly around in helicopters and see really cool things, you know. So that part is good. People, but you know, at the same time, we're usually there. I really enjoy it when we're doing those studies on an area that could have a spill. So we're looking on how we can protect it in the future because there's no spill going on, or looking at them by doing the same things, being out in the environment for the long-term recovery, because then you can see nature come back. So, but I do think that the best part of my job is seeing things that I never would have dreamed of when I was a kid, and having those opportunities to see things all over the world that I didn't even know existed. And I find new things every day that I didn't know existed. And that's the part I love about the job, is continually learning and exploring. So.
Well, that's great. That's a good place to go back to your talk, because we've gotten a number of questions about the wildlife and the marine life and the shorelines and how those are impacted by spills. And I think you're going to cover that in some of your lessons learned, Gary. So I will turn it back over to you.
Okay, we'll get to some of that. And I thought we would kind of begin to wind things down by talking about, well, what have we learned about oil impacts on the environment and our efficiency in cleaning it up. So we'll start with this one from Alaska, our first lesson learned. And, you know, I mentioned that we spent a long time studying the effects of the Exxon Valdez oil spill on Alaskan shorelines. And this was one of the, it's kind of obvious, but one of the things that we studied up there. And we learned that using high pressure hot water, and a lot of it, on those relatively pristine Alaskan shorelines was maybe not the best idea. The shorelines did recover from that, but it took a little bit longer than the shorelines that were simply oiled. So we have that as a lesson learned. Here's one that's important, both from Alaskan studies after the Exxon Valdez and then from the Deepwater Horizon. The results are very consistent, and that is that baby fish are really, really sensitive to oil exposure at very, very low levels. And we first began to suspect that with salmon up in Alaska, but it's something that also has been very well studied after the Gulf, the BP spill in 2010. So what you see in this picture, it's a yellowfin tuna a pair of embryos, and the top one is a normal yellowfin tuna baby fish. The bottom one is a yellowfin tuna that's been exposed during its development to low levels, very low levels of oil. And so you can see that it looks deformed. If you could see its heart, you would see problems with heart development. So that's one of the basic new stories that we've learned from a lot of the research that's taken place after the big oil spills, that baby fish are really sensitive to low levels of oil. So the third lesson, before the Exxon Valdez spill in Alaska, we thought that maybe marine mammals, since they're so smart, might simply avoid oil spills, but we know now that they don't. And the shot on the left there shows some dolphins right in the middle of a slick of oil. And so obviously they did not avoid the oil. And we've learned that when they are exposed to oil for a longer period of time, like in some of the coastal waters of Louisiana, they get very, very sick. And so this is a story that has been very, very well studied. There are ongoing studies that will look at the impacts to marine mammals, but this is one of the lessons that we've learned from the Deepwater Horizon as well as the Exxon Valdez. Now, as far as sea turtles go, we didn't know a lot about sea turtles before the Deepwater Horizon, but the Gulf of Mexico is home to 5 or 6 different sea turtle species, and they were exposed to oil. They often tended to congregate where the oil did, and so a lot of them were very heavily oiled, and they were rescued at sea by people in boats, brought into rehab centers on land, and cleaned up and then held until they were healthy again. And it turns out that sea turtles were pretty hardy. They were pretty resilient. Once you got the oil cleaned up off of them, they did pretty well and recovered well. And most of them were released back into the ocean. Birds. I think somebody's already asked about birds, but birds are very sensitive to oil. And we always see pictures of oiled birds when there's a spill of any magnitude that occurs. We've gotten a lot better at cleaning them up over time, and it's taken a lot of trial and error, but we do much better now. So that leads me to the following question. Why do you think birds are so sensitive? And what do you use to clean them up? What's the best stuff? So Nicole, I'll let you field some responses.
Let's see, what do you guys think? Well, Luke thinks it's because they have feathers, that they would be sensitive to oil. Leanne thinks you use water to clean them up, or a sponge. A couple of people are talking about Dawn dish soap as something that can be used to clean them up. And let's see, did I say, oh, and someone says because it gets stuck to their feathers, so they're vulnerable because the feathers stuck it in. Somebody, Juan thinks baby shampoo might work on birds. But we're getting a lot of, at least a handful of the kids are thinking about Dawn dish soap. Is that where you're going with this, Gary?
Well, I might be. First, let's talk about the feathers. You know, the feathers are pretty amazing things. So I've got some feathers here that we use in some of our classes, and they're kind of cut off here at the top, if you can see that. But they're amazingly fine structure, and so you see down here on the feather, it's kind of downy. That's the part that you find inside your sleeping bags and inside your jacket. That downy part keeps the bird warm, and that's why we use it in coats and stuff. So the shot on the right there that you see on the slide is a photo I took this morning with a digital microscope that we have of this feather. And it just shows that very fine structure. You don't normally think of feathers being really complicated in the way that they're built, but there's a reason for that. And so the outer part of the feather, the part that you see on the outside of the bird, which is pretty much here, protects that downy part. And that's what keeps the bird warm. So when oil gets on the feather, it kind of disrupts the structure. So I have a pretty simple little demo here. Let's see if it works. A bowl of water and the feather. Now I'm going to dip this feather into the water. And first of all, what do you think is going to happen when I dip the feather into the water?
Let's see, you guys have any ideas? It's gonna, a lot of people think it's gonna get wet, Gary. They're really smart.
Boy, can't put anything past these kids, huh?
Bridget says it's gonna float. Lou thinks it might repel. Rebecca thinks it might get heavy. And Duncan thinks the hairs are gonna come together.
All right. The feather, I'm gonna dip it in the water, and what do you think? I mean, that downy part kind of looks a little wet, but look at the upper part. It looks pretty good, huh? Now, here's the other part of the demonstration, and we'll see if this works. I have olive oil, which is my surrogate, my stand-in for real petroleum oil. I'm going to pour just a wee bit of olive oil into the water. We'll take that same feather, which is looking not bad. Now I'm going to put it into the oil and water mix, swirl it around, and look at it now. Can you see that?
Yes, we can.
It looks ugly. And so that's what happens when a bird gets oiled. It disrupts all of that really cool structure you're seeing inside here. And so the bird can no longer, it can't fly, of course, but it can no longer keep itself warm. So that's why a lot of birds begin to suffer from hypothermia. So we better move on. But you're right, those people who said that Dawn was the stuff of choice to clean up birds. I took this photograph at a bird rehab center in California, and they are well stocked with Dawn. That's what the rehabilitators over the years have found works best in cleaning up birds. So, you see it in commercials for Dawn, but it's true. It really is quite effective in cleaning up a lot of the oil that occurs. All right, so we're in the home stretch. We're running a little late, but we're in the home stretch. I just wanted to talk about some of the risks and rewards. When we go to an oil spill, there are a lot of things you don't really anticipate are going to happen. I mentioned that was part of the challenge of responding to an oil spill. You have to be light on your feet. You have to be ready for unexpected things. Well, here are just some examples. So in Bangladesh, we had armed guards with us when we were out doing surveys for oil. And you might ask why. One of the reasons was because the area where we were also is one of the last remaining habitats for Bengal tigers. And so I really wanted to see one of these guys when we were out doing the surveys, but this is as close as I got, was seeing a footprint, a recent footprint in one of the areas that we were surveying. Similarly, up in Alaska, this is a photograph I took of a mother bear and her 3 cubs that chased us off of a beach that we were surveying, and that's part of the protocol. It's their beach, right? And so we had to pull off and wait until they were done feeding on the shoreline, and then we could go back ashore to continue our survey. In Chile, a minefield, I was on my way to an old spill site at the very tip of South America, and it's still got mines in it. So not something that you really learn about when you're getting ready to go to a spill or studying it in college. And then up in Alaska, when we were doing a shoreline survey, we encountered explosives on the shoreline. Who knew why? But the rewards are many in what we do, and these are a couple of shots of the people that we work with, both within NOAA and our contractors and our support people. And it's very important to recognize that what Charlie and I do is not just us. It's a whole team of scientists and other people who are supporting us, the oceanographers and modelers and the administrative people who back us up and help us travel. So, I want to recognize that Taylor in Biloxi, Mississippi has an aunt who works with us very closely here in Seattle, her Aunt Amy. And she is great. She's part of our team. We really rely on what she provides to us. Same thing for Jack and Ollie in Columbia, South Carolina. Their mom is one of our supporting scientists who helps us a lot on shoreline surveys and a bunch of other stuff looking at resources at risk. So it's really a team effort, and that really is one of the rewarding things. There are some amazing people that we work with. And the last thing I wanted to mention was that, Charlie gets to meet governors and probably senators and deals with Coast Guard admirals, but I don't think Charlie has a signed photograph of Miss Louisiana like I do. So I definitely count that in the rewards category.
I can't compare, Gary. Yeah. I can say, though, that my NOAA pin that I usually have on spills, one of our NOAA pins, our enameled NOAA pins, is actually in the Royal Jewels now, with some small country in Europe when I met the king and queen of that country. But that's the best I could do. So yeah.
Wow, that's not bad, Charlie. That's not bad.
Yeah, I'm sure you never made it to the Royal Jewels, but I gave it to them anyway. And they were appreciative. So.
So the kids have some more questions for you, Gary, and actually to both of you. A few folks have asked, how long have you been doing this? You talked about your career path, but can you sum it up for us in years?
Okay, I will say that I've been doing this since a little over 30 years, about 34 years since I got out of, once I started doing science. 1985, I guess, is when I started doing this type of work, and that was when I was at Louisiana State University working for NOAA to do the chemistry role during spills. So a long time.
Wow.
And in that time, I probably responded to over 300 oil spills and did a lot of development work as far as understanding the chemistry of oil and how to fingerprint oil so we can tell different ones from different sources. But a long time. Most of my career has been dedicated to chasing oil spills around the world and around the U.S. Gary?
Yeah, I haven't been doing oil spills for as long as Charlie, but I still feel like I can begin to measure my career in geologic time versus, normal time. But I've done oil spills for probably a little over 30 years, and I've been with NOAA for over 40. So it's getting pretty near geologic.
Yeah, I just say that, like Gary, my daughter wasn't born until after the Exxon Valdez oil spill, and now she's off in Austin as a software engineer. So she's grown up as I chased oil spills. So it's been a long time.
Well, so obviously you guys are experienced veterans, so you can answer a question like, what is the biggest oil spill that you've helped with? Lindsay wants to know.
Okay. For me, the biggest oil spill was actually, and it was a long time ago too, in 1991. They had what they called it was called the Arabian Gulf oil spill. It was after a war in the Middle East, and in Kuwait. And that's the one also had all the well fires. It also, from the damage to the tanks, it became the largest oil spill that I know of. Gary actually is a historian on oil spills, but I believe that was the largest oil spill that had a man-made impact associated with it. Man either created the environment that the oil was in, or man caused the oil spill. So I think the Arabian Gulf oil spill, which was like much even bigger than the spill in the Gulf of Mexico, was the largest I ever worked on. Gary?
Yeah, I can't beat that one, Charlie. So,
No, but Gary knows the biggest spills of the U.S. Gary's been everywhere. You know, I was just saying, Gary and I have actually competed on this because sometimes Gary gets to go places and go, gosh, I wish I could have gone there with Gary or been there, you know. And Gary says some of the things about some of the opportunities I've had. We are a team, and you know, there's a bunch of us, and we've been fortunate through our careers to have lots of good opportunities. Unfortunately, sometimes it's because there's an oil spill, but to go and see lots of things that we never would have thought we'd have saw before. But Gary, you also should say the amount of gallons doesn't mean the amount of magnitude, the impact to the environment. Gary's seen some things that took a long time for the environment to recover, or sometimes never even recovered from in his studies. So it's not so much the volume sometimes, it's where that oil is. So you can add to that, Gary.
Yeah, you know, Charlie, that's an important lesson. It's not necessarily the amount of oil, the size of the spill, but it's also the sensitivity of the habitat, like that area in Bangladesh, which is the largest remaining stand of mangrove trees in the world. You hate to see oil spilled in an environment like that. So it can be a relatively small spill, but if it's in a really sensitive area, then we really worry about that.
Got it. Okay. What is the weirdest thing that you've encountered when cleaning up an oil spill?
Gary?
Besides Charlie, right?
Yes,
well, I tried to show some of the more unusual things in the risks and rewards. We were doing a shoreline survey in Alaska and found a human skull, which was a little off-putting. One doesn't normally expect that sort of thing. So, Charlie, I don't know what the weirdest thing was that you've encountered.
Well, I will take a little different tact on that. One of the weirdest things as far as cleaning up oil spills is for a while, there was this big effort for people to donate their hair, and they'd collect hair in barbershops, or people would actually cut long, beautiful hair and they would donate it for help cleaning up oil spills, because someone came up with this idea of taking all this hair and put it in booms to help sorb the oil, and because a natural sorbent. And it really didn't work that well because it would get saturated with water, like those feathers kind of, and it'd sink to the bottom. It was not a very good sorbent. And so I went and did a kind of a campaign to say, no, don't do this anymore. Don't donate your hair. And I found that people got mad at me because a lot of people had donated their hair to clean up oil spills. So that was the weirdest thing I was ever involved in. Yes.
Okay, I've got one more for you. Well, let's see. Luke was asking generally, and Gary, if you don't mind, you could maybe stop sharing your slides. We might be able to see you guys a little bit better. If it's easy, if it's not, that's fine. I was curious, Luke wants to know how many oil spills do you usually work on in a year?
Well, that's a good question. So our organization, our group, of the Emergency Response Division, probably responds to, sometimes just by phone or going on scene and working, probably to about 150 to 160 oil spills a year. When I was the SSC in the Gulf of Mexico, the Science Support Coordinator in the Gulf of Mexico, pretty regularly each year I'd probably work 30 or 40 oil spills. Now, a lot of those were real small. They were small spills from a fishing vessel or a little leak, and it wasn't a big problem. Then some of them were very big problems that would take months to years to respond to and recover from. So it varies a lot. Gary has a different view on it. I mean, we have different roles sometimes on spills, and the number of spills we get involved in change and varies a lot. So Gary, how would you characterize that question?
Well, it really filters down a lot from the Coast Guard. The Coast Guard responds to thousands of spills every year. We get called in NOAA for maybe 100, 200 spills a year. And then in terms of what I get called on personally, it's maybe a very small subset of that, because most of the calls that we get are along the lines of where's the oil going to go, that sort of thing. And so our physical oceanographers are very busy trying to figure out with computer models where the oil is going to go so that the Coast Guard can understand what the potential impacts are going to be. But I typically get called in for biological questions on a much less frequent basis. So it's gone through the filter of people like Charlie, the scientific support coordinators, who then ask questions of the oceanographers, who then may ask questions of the chemists. And then by the time it gets to us, it might well be a fairly serious incident, because then people are worried about impacts to the resources.
Well, I will add to that, though, is that a lot of us doing the work on the front end don't have the same opportunities Gary does on the back end. Gary does a lot of the longer term research, and some of my most rewarding time periods in working for NOAA and responding to oil spills was doing some of those long-term studies with Gary when I would be invited out to help him with some of the field work and all in Alaska and other places. So we all have different opportunities and different roles. The number doesn't matter as much as what do you do and what you learn from it. And that's what I said. I think that there's many different roles on responding to oil spills, and we all do it, and we've been doing it for a long period of time because we get a lot of personal reward from doing it, because we think we're doing things that really help. And I think that's why it's our number one motivation is we know by the work that we do that things get better, and that's why we do it. So.
And we invited Charlie out on our research projects up in Alaska, mainly because he's kind of a bigger guy and can carry a lot of equipment. So he was a great porter for those research studies.
I was happy to be a porter, though. It was great. So, yeah.
Well, I think the other thing that we can share with our kids is the long-standing friendships and relationships that are developed across our mission. Like, it's obvious that you guys have worked together a long time and really enjoy each other. So I would put that plug in too. We make a lot of great friends working at NOAA. Before we go, I think I'd be remiss if I didn't make you put on the equipment that you were going to show the kids. Yes, there it is.
Yeah, it's supposed to protect our
Charlie.
Yeah, so yeah. So.
All right, great. And sometimes we have to wear masks too. That's right. Awesome. Well, thank you guys so much for your time today. It's really amazing that we can bring you to all these kids across the country, and from Alabama and Seattle and us here on Cape Cod. So thank you so much. I want to encourage everybody to look in for next week's webinar. We have a whole new program, and we're starting on Mondays with hurricanes. So take a peek and sign up. And thanks, guys. I hope you guys have a great weekend. Thanks again for helping us out on NOAA Live.
Thank you all. Have a great day.
Thank you all.
Bye-bye.